Hello everyone, this is Chen Zhao from EE538. Today I'm going to present my final project, and I do not have a teammate.
This is an outline of what I have done. Here are some trivial functions and their results. For find nearby function, I used the min heap to store the found results to improve runtime. The spelling correction function was achieved by combining DFS with dynamic programming. In the DFS, I iteratively search the three values and calculate the added distance based on the equation. The calculated value were stored in the 2D vector as memorization, and this figure shows a correction from a wrong name to the correct name. Here I'm showing you a crazy example to calculate added distance with and without memorization. With memorization, the runtime was less than 400 milliseconds, but it couldn't be finished in 2 minutes without memorization. For calculate shortest path, digestion algorithm was first implemented. This is the algorithm, and I need unordered maps to store visited nodes, predecessors, and distance information. I also need a min heap to store the nodes with minimum distance to initialize every iteration. Bellman-Ford algorithm was also implemented. We don't need to record visited nodes this time. A stop sign is useful for early stopping when no more updates were found, and this can accelerate the runtime a lot. This table shows the comparison of the two algorithms. I tried three different inputs. As you can see, Digestra is significantly faster than Bellman-Ford for this problem. Here I put the results of the three searches from Trojan Map and Google Maps side by side. Almost the same paths were found. Now we are moving to traveling Trojan function. We first solved the traveling salesman problem with brute force. Then we used the backtracking technique to stop the branches with greater value than the mean value earlier. Backtracking will help us to speed up our program a lot. I also implemented two-opt algorithm. Different from the previous two algorithms, two-opt is a heuristic function that does not guarantee the optimal result, but can significantly reduce runtime. Here I try to test the three algorithms with three different numbers of places. Backtracking is faster than brute force, but two-opt is much faster than the two algorithms. In my testing, the three algorithms generally give the same results, but two-opt sometimes give a little longer path, which is actually expected. The next function is cycle detection. Here I'm showing you two examples. One is with a very large area, and it is not surprising that there are cycles in such big area. The other example shows you the case that a cycle is not found in this narrow area. The last function is delivering children that uses topological sorting algorithm. I used the stack to store nodes in topological order and reduce runtime. Here is an example with 9 nodes and 11 edges. This final road of the delivering children is shown on the map. First, I would like to thank Professor Arash. I learned a lot from this class. Specifically for this project, I learned that DFS is everywhere, and dynamic programming and backtracking saves runtime a lot. Appropriate algorithm is important for specific problems. If you think about Bellman-Ford and Digestra, stack, queue, and heap are helpful to reduce runtime. And finally, a heuristic method is useful with the trade-off of runtime and accuracy. In the future, I would like to learn more and implementing more about the more efficient algorithms. And also, I would like to complete the UI programming for this interesting project. Thank you very much for your attention.